Hello dear viewer, my name is Ernar Sakarbekov and this is my video blog. In the world history there are many great discoveries and I can argue that one of them is this chemical reaction. Nitrogen molecule plus 3 hydrogen molecules react to form 2 ammonia molecules. The industrial implementation of this chemical reaction is called Haber process. The process was named for the great German scientist Fritz Haber, who received the Nobel Prize for his discovery in 1918. Let's look at the problems that he solved. The major component of air, nitrogen, can be just used up by plants due to the strong triple bonds between atoms that hold these two atoms together so tightly so they cannot react chemically. Fritz Haber found a way how to use nitrogen from the air and make it reactable for further transition to the ammonia form. Nowadays, Haber process, producing more than 130 million metric tons of ammonia per year, is considered as one of the largest chemical industrial processes in the world. To explain Haber's method, you need to know the term chemical equilibrium. Haber process is a reversible reaction, which means that produced ammonia can break down again to the nitrogen and hydrogen, and vice versa. Chemical equilibrium occurs when the rate of forward reaction is equal to the rate of the reverse reaction. The forward reaction means the direction which leads to the formation of ammonia, and reverse reaction actually means the direction which leads to the formation of reagents, nitrogen and hydrogen. So, chemical equilibrium doesn't have to be in the middle. It happens when the concentration of reagents and products do not have tendency to change with time. So, at equilibrium you usually do not know more reactants or more products you got in final stage. And in order to avoid this uncertainty, specific conditions are used in industry to shift equilibrium towards a product, or by other words, ammonia. Adjustment of these conditions refer to the principles designed by famous French chemist Henri Louis Le Chatelier. Using Le Chatelier principles, Fritz Haber found desired conditions. By increasing the temperature and pressure in an enclosed container with fixed volume, the equilibrium will shift toward the product. So, when you try to disturb the equilibrium, the system will try to recover it. That's a connection between system and equilibrium. So imagine the situation. In closed container there are molecules of nitrogen, hydrogen and ammonia. We got a chemical system in this container, so container with these molecules. When we increase the temperature, it acts as an external source of disturbance. We disturb the equilibrium, and it increases the kinetic net energy of molecules, and thus increasing the rate of collision between particles, which in further lead to the formation of ammonia molecules. You can see that the collision of particles, or by other words the collision of molecules between nitrogen and hydrogen, leads to the formation of ammonia molecules. Increasing the pressure in the same container would cause packaging of these molecules closer to each other, and this is not the case of chemical equilibrium. Therefore, system will try to recover equilibrium by decreasing number of molecules, and the only way to achieve it is to make molecules of nitrogen and hydrogen react with each other, producing molecules of ammonia. At a certain point, equilibrium recovers and reaction stops. So, let's turn to our Haber process. Haber process starts in closed container called compressor, and all reagents are in the gaseous form. In next stage, reagents flow to the container with catalyst in form of iron. Catalyst is a substance that increases the rate of chemical reaction and left unchanged by the reaction. Iron increases the rate of forward reaction. Increasing the temperature to 400 Celsius degrees and increasing the pressure to 250 atmospheres also contribute to the shifting equilibrium toward the ammonia. In final stage, gaseous mixture goes to the condenser, where ammonia is condensed and removed in liquid form. At any such cycle, the yield of ammonia is 50%. Consequently, some unreacted nitrogen and hydrogen left. And to increase the yield of ammonia, unreacted gases go to the recycling process. By recycling, overall production yield reaches 97%. Nowadays, ammonia is used in many purposes such as fertilizer, cleaner, fermentation, antimicrobial agent for food production. But the major purpose is fertilization of soil by ammonia and its salts. When applied to soil, it helps to provide increased yields of crops such as maize and wheat. Fertilizer generated from ammonia, produced by the Haber process, is estimated to be responsible for sustaining 1/3 of the Earth's population.